Now that we've learned how to manipulate rational expressions algebraically, let's talk about solving equations that involve rational expressions. And so here I have 3 over x plus 1 is equal to 4 over x plus 2. A simple equation like this can be solved via cross multiplication. So what I'm going to do is multiply both sides of this by x plus 1 and both sides of it by x plus 2 to clear the fractions. Now I'm working with an equation though, so I'm going to move down to a new equation. 3 will get multiplied by x plus 2, bringing this one over, and that's equal to 4 times x plus 1. So if I have a solution to this equation, then it must also be a solution to this equation. And this is effectively a linear equation after I combine the terms. So I have 3x plus 6 is equal to 4x plus 4. Bringing 4 to one side and bringing 3x to the other side, turns out x would have to be 2. So x equal to 2 is a solution to this equation, and let's just check that it's really a solution to our rational equation. I'm going to plug in 2 for x here, and I get 3 over 2 plus 1. That's 3 over 3. It's going to be 1. I'm going to plug 2 into the other side. I'll have 4, 2 plus 2. That's 4 over 4, and that's also 1. They agree. So yes, this is a solution to my rational equation. Let's look at another one. Let's take 4x squared minus 2x over x plus 3. And notice now it's equal to 0. Notice x equal to minus 3 could not be a solution. It's not in the domain of this expression, so we can't even consider that value. And notice now I've got 0 on the right-hand side, so if I was to multiply both sides by x plus 3, I would get 4x squared minus 2x is 0. And so in order to find when a rational function is equal to 0, you effectively need to determine where the numerator of that expression is 0. In this case, I'm going to factor out 2x. And I need that to be 0. Looking at each factor, x could be 0 from this factor here, or if I solve this one for x, I'll get x equal to positive 1/2. Here are my two solutions. Notice that 0 is in the domain and 1/2 is in the domain. Neither of them result in division by 0 in the original expression, and therefore those are legitimate solutions. One more example. Now I have multiple terms in the equation, and I could, for instance, simplify this expression here to one term and then proceed like we have in previous examples. But you do have some options here when working with an equation. You could clear the fractions to get rid of all the denominators and turn this into a polynomial equation. And when I do that, what I'm going to do is multiply both sides by enough stuff to make all these factors in the denominators go away. So in this case, I'm going to multiply by x squared minus 1 to clear this. And notice that includes a factor of x plus 1 and a factor of x minus 1. We're going to apply that to both sides of the equation. So when I multiply it by this term here, the x plus 1 will cancel out, but I'll still have a factor of x minus 1. When I multiply it by this term here, all of the x squared plus 1 will cancel out, equal to, and then when I multiply 5 times this stuff, the x minus 1 will cancel. I'll be left with x plus 1. And now I have a polynomial equation. In fact, it's linear, and I should be able to solve that. So let's distribute everything out. 4x minus 4 plus 10 is equal to 5x plus 5. I'm going to combine like terms. 10 minus 4 gets me plus 6. And let's bring the 5 over to get 1 and bring the 4x over to get x. And so x equal to 1 is a solution to this linear equation that I solved here after clearing the fractions. But be aware, that number is not in the domain of the original equation. I can't put it here and I can't put it here. So even though it satisfies this equation, it doesn't satisfy this one. And therefore, there are no solutions because this is not in the domain of my original equation. This generally happens in rational equations. You have an expression that involves division and you turn it into one that doesn't have the division in there. In those places where the denominator could be 0, going backwards and dividing towards this equation would result in division by 0. Let's look at one more example of solving a rational equation. I have 4 plus 7 over x minus 2 is equal to minus 1 over x plus 1. And the first thing I'm going to note is the domain of this equation. I cannot be putting in 2 or negative 1. So they have to be excluded if indeed we get any of those values as solutions. I'm then going to multiply both sides by enough stuff to clear those fractions. In this case, I need a factor of x minus 2 and x plus 1. Each term of the equation will get multiplied by that. So the 4 will get multiplied by it. The 7 will get multiplied by it, and a factor of x minus 2 will cancel, leaving x plus 1 equal to minus 1, and now the x plus 1 will cancel, and we'll be left with a factor of x minus 2. And you have some new polynomial equation to solve, and you proceed to do that by combining like terms. So let's start multiplying everything out now. 4 foiling out, that will be x squared minus x and minus 2. Plus 7x plus 7 is equal to minus x plus 2, distributing the sign. Just work patiently, distribute everything out. Distributing the 4. And starting to combine like terms, now I see a quadratic term, 4x squared, that's the only one. I'm now going to start to look for linear terms. Minus 4x plus 7 gives me 3x, and then I'm going to add 1 over to this side to get me a total of 4x. Minus 8 plus 7 gets me minus 1, and I'm going to subtract the 2 down, that's minus 3. And now we've got all the terms on one side, 0 on the right-hand side. Let's see if we can factor this. I'm just going to take a guess at maybe using, I need to have x squared, and I need to get a product of 4. So I'm just going to try 2x and 2x. The last two terms should multiply to give me 3. So I'm going to put 3 and 1. And if I go 6x minus 2x, that will get me positive 4x. So I'm going to put a plus there and a minus there. And notice that that does give me the right sign when I multiply together to get minus 3. So solving each one, x is equal to minus 3/2 from this one, and x is equal to positive 1/2 from this one. Those two numbers are solutions to my quadratic equation above, and they are in the domain of my rational expression, my rational equation, so they are solutions to my original equation as well.